big is a piece of gravel anyway? Because, like, I can see a piece of gravel with my eye, but like, how big does a particle have to be considered gravel? I like to pretend that this represents gravel because it's like the biggest particle size, but this is, of course, super blown up. Gravel can apparently, according to geologists, be anywhere from 2 millimeters in size all the way up to like 60 millimeters in size, which to me that's like a rock. That's not exactly a little piece of gravel.
Psych! This chart says gravel can be over 4 meters in diameter.
Sand is a way smaller particle size than gravel, but you can still see 1 grain of sand with your eye. Clay is actually one of those things that a lot of people are like, clay's like really big because you know you can like make a ball with it. Turns out that one piece of clay is so small it's invisible to your naked eye. And instead of it being round like sand or gravel, it's flat like a penny, and it's like microscopic.
Like we talked about last time, not only is clay made of a bunch of stacks of flat particles, its spaces are also not connected. So it's really hard for water to get through.
So it's really hard for water to get through. Have you ever seen like one of those ball pits? There's lots of spaces in between all the balls.
Do you think it's easier to move through a pit of golf balls? Or would it be easier to move through a bunch of basketballs?
This brings us to
Permeability. Yeah, last time we talked about like porosity as a vocabulary word, and we said it was the space in between particles. And we figured out how much space was in between different particles by pouring water into them and then like measuring the amount of water. Permeability is kind of related. It is not a measurement of the space, but it's a measurement of how fast water soaks through. So permeability is wow. So it has to do with water and it has to do with particles, but this time instead of measuring how much, we're going to be measuring how long. It's time to test permeability.
results.
We can see that even though I put the water in the gravel the last, it was the first one to let all the water through. So it's safe to say the gravel is the fastest. Sand got the water second, and it's letting the water through more slowly, and it's currently still dripping. Clay got the water first, and its cup is still 100% empty, so no water is getting through. So because of the experiments that we did today, we learned about 3 particle sizes: gravel, sand, and clay. And then we found out that even though sand is way smaller than gravel, they can hold the same amount of water, just with tinier spaces in the sand. Now for permeability, we learned that these 3 particle sizes have very different permeabilities. We learned gravel is super permeable. It lets the water through really fast. Sand is permeable, but not as permeable as gravel. And then clay, turns out, it doesn't let the water through at all. And there's a special word for that. It is impermeable. And impermeable means it does not let water through at all.
What if we waited 200 years? Would the clay eventually let water through?
Next time on SLU School, we're going to find out what this porosity and permeability has to do with groundwater.